For years, there was one way to make AI smarter: throw more data at a bigger model. That was the law. Then in late 2024, OpenAI broke it. They took a model that scored 9% on a hard math benchmark and, by giving it more time to think during inference, not more parameters, pushed it to 96%. That jump, from 9 to 96, is the story of test-time compute. And it might be the biggest shift in AI since the transformer itself. Let me show you the difference. The old way, which almost every AI model still uses, works like a reflex. You ask a question. The model processes it in one forward pass. Out comes an answer. It's fast. It's cheap. But what you get is whatever the model already knows. The new way is different. The model doesn't answer right away. Instead, it generates an internal thinking trace. It writes down steps. It checks its own work. It backtracks when it hits a dead end. It tries another path. Only after this internal loop does it output an answer. Standard chain of thought is a linear script: step 1, step 2, step 3. But this new reasoning is deliberative. It loops. It searches. It self-corrects. It's the difference between reciting from memory and working through a problem on a whiteboard. Chain of thought started as a simple trick. In 2022, Google researchers found that adding the phrase "think step by step" to a prompt dramatically improved results. It forced the model to expose intermediate reasoning as text tokens. Then in 2023, self-consistency showed you could scale this further. Generate multiple chain of thought paths, take a majority vote. More paths meant better accuracy. That was the first real taste of test-time compute scaling, spending more inference tokens to get better answers. But here's the thing a team at Berkeley proved in 2024. Optimal test-time compute can match the gains of using a model 8 times larger. 8 times. For hard problems, sequential search, where the model iteratively refines its answer, works best. For easy problems, parallel sampling, just voting on multiple attempts, is enough. OpenAI's O1 and DeepSeek's R1 pushed this further than anyone imagined. They generate thousands of thinking tokens per problem. The model learns to verify its own steps, backtrack on errors, and explore alternative approaches. It's not just code anymore, it's a genuine reasoning process. When you're generating all these reasoning traces, you need a way to pick the good ones. That's where reward models come in. An outcome reward model, an ORM, looks only at the final answer. Is it correct or not? Simple, cheap, works well for easy problems. But it has a blind spot. A model could stumble through terrible reasoning and land on the right answer by luck. The ORM would call that a success. A process reward model, a PRM, is more precise. It scores each individual step in the reasoning chain. Did step 3 make a logical error? The PRM catches it, even if the final answer happens to be right. Now here's where it gets interesting. OpenAI found that PRM-guided search has a much steeper scaling slope than ORM. For hard problems, a good PRM is worth 10 times more samples. The modern approach combines both: use an ORM for cheap filtering, then a PRM for detailed search. DeepSeek R1 took a different path. They used outcome-based reinforcement learning and let the model learn its own internal process rewards implicitly. No separate PRM needed, the model becomes its own critic. Let's talk about the two models that define this moment. OpenAI released O1 in September 2024. It hit 56% on AIME 2024, the hardest high school math competition in the US. Then O3 dropped in December. It scored 96%. 96. And on GPQA Diamond, a PhD-level science benchmark, it hit 87%. On Codeforces, its ELO rating hit 2,600, which puts it in the top tier of competitive programmers. O3 uses adaptive compute. It learns how many thinking tokens to spend on each problem. Easy question? Quick answer. Hard problem? The model decides to think longer. Then DeepSeek R1 hit in January 2025. This was the watershed moment for open source AI. A 671 billion parameter mixture of experts model trained with group relative policy optimization, no critic network, just group relative rewards. It scored 80% on AIME, 90% on Math 500. But the real bombshell was this: DeepSeek open sourced everything. The model weights, the training recipes, and crucially, the distillation process showing how to train smaller models on R1's reasoning traces. Now for the hard truth. This kind of thinking is expensive. A standard GPT-4o query costs about 200 tokens. O1's thinking traces run around 5,000 tokens. O3 can hit 10,000 tokens or more per query. That's 100 times more compute per answer. The economics are stark. Direct GPT-4o is 1x cost. Chain of thought with 5 samples is about 5x. O1 is 30x. O3 can be 100x or more. But accuracy goes from 9% to 96%. You pay more, but you get dramatically more capability. The returns follow a curve. First 10 samples? Big gains, 5 to 30% accuracy improvement. 10 to 100 samples? Smaller gains, 2 to 10%. Past 100 samples, things flatten out for most approaches. But here's the thing: the real solution isn't to spend the same compute on every query. It's adaptive compute. Easy problems get cheap, fast inference. Hard problems get expensive, thorough reasoning. O3 does this internally. The model decides how much to think. Snell's team formalized this as coverage-based scaling. Use a small model to estimate problem difficulty, then route easy questions to cheap inference and hard ones to expensive search. This is how reasoning becomes practical at scale. The biggest surprise of 2025 is that reasoning isn't locked behind closed APIs anymore. DeepSeek R1 distilled to just 32 billion parameters achieves 72% on AIME 2024. That rivals O1 Preview. A model that fits on a single consumer GPU, running locally, no internet required, matching one of the most hyped releases of 2024. The key insight is distillation. You take a massive model like R1 and 671 billion parameters and generate reasoning traces from it. Then you train a smaller model on those traces. The small model learns the process, not just the answers. It learns how to verify, backtrack, and explore. Alibaba's Qwen team released QWQ32B Preview with an Apache 2.0 license. Strong math. Strong coding. Extended COT with verification loops. Completely open. The ecosystem is growing fast. OpenThoughts released OpenThinker with fully open datasets. AI2's Tulu 3 uses RL and PRM-based tuning. Sky T1 built a data synthesis pipeline for reasoning. Marco O1 attempted an open replication of O1-style thinking. The trajectory is clear: within a year, 7 billion parameter models will reason well enough for on-device use. Phones. Laptops. No connection needed. Where does this all lead? A few places. First, infinite test time compute. Given enough time and compute, a model should solve any problem in a formal domain. Think AlphaGo level search, but for language. If it can be verified, math, code, logic, the model can keep searching until it finds the answer. Second, tool use during reasoning. This is already happening. Models that search the web mid-thought. Execute code. Query databases. Use the results to inform the next reasoning step. O3 reportedly uses internal code execution during its thinking process. Third, better reward models. PRMs are still the weak link. The frontier is automated PRM training without human labels, self-play, synthetic data. And multi-dimensional PRMs that score correctness, efficiency, and safety all at once. Fourth, small models that reason. The distillation results suggest we'll see 1 billion to 8 billion parameter models capable of strong math and code reasoning. On device. Specialized for medicine, law, science. But there are real safety challenges. Longer reasoning chains mean more surface area for jailbreaking. 10,000 token thinking traces are harder to audit. There's even concern about deceptive alignment, where a model appears to reason correctly while planning something malicious. This is an active, urgent research area. Here's the bottom line. Test time compute is a new scaling axis. For years, we believed that smarter AI meant bigger models and more training data. Now we know there's another path: build models that think longer. The key tension is cost versus accuracy. And the answer is adaptive compute. Spend little on easy questions. Spend a lot on hard ones. This is how reasoning becomes practical. The open source ecosystem has already democratized this capability. DeepSeek R1, QWQ32b, these models are free, they run on your hardware, and they reason surprisingly well. This is the biggest architectural shift since the transformer itself. Inference used to be about knowledge retrieval: what does the model know? Now it's about thinking: how does the model reason? That changes everything. Try DeepSeek R1's distilled models or QWQ32b today. They're free, they're open, and they reason surprisingly well on a single GPU. Drop a comment: would you pay 100 times more for a model that thinks for 30 seconds before answering? Subscribe for more deep dives into how modern AI actually works.